In the last video, we discussed about testing the hypothesis for the population mean when the population standard deviation sigma is given, right? But as we saw in the confidence interval, when the population standard deviation sigma is not given, then we need to use the t-table, right? So similarly for the hypothesis testing, we need to use the t-test. We call t-test for the mean. That means when sigma not given. When the sigma is not given, then we need to use the degrees of freedom, that is given by the sample size minus 1 and minus 1. Okay, we need to, again, we have the two methods. One is the critical value method and the other is the p-value method. Okay, so p-value method can be applied directly from calculator. For the critical value method, you will have to do it. Okay, so first of all, let me review how would you find the critical t values when alpha is given and the sample size is given, okay, and the tail of the test is given. What it says is find the critical t value for alpha is 0.05, n equals to 20, and right tail test. Okay, so how do you do that is, let us make a normal curve. 0 is in the middle, right? And then alpha is 0.05, right tail test. Right tail test means you will shade only on the right side. So 0.05, so this is denoted by t alpha because you are shading only one side. If you say two sides, you will write t alpha half like that. Okay, now you need to find out what is that t alpha, what is that value. So the degrees of freedom here is 20 minus 1, that will be 19, right? So let us use, because you need to find out the t alpha, we need left area. What is the left area? The right area is 0.05, so the left area is 0.95, right? 95. So that value is 0.95. That is the left area. So what do we do next is go to the calculator and then clear whatever you have there. Second verse, go to the inverse t. Okay, that is inverse t. What is the area to the left? 0.95, right? What is the degrees of freedom? Is 19. Okay, and then you hit paste. If you do that, you will get 1.7291. That is the value of t alpha. That will be, you see that, 1.7291. That's what you do. Okay, now if you want to use the table, you need to go to the table, right? You see that in the chapter 7 we had the table for the t distribution or the t table. So you need to go to the t table in chapter 7 if you want to use the table. Okay, this is the t table. So for one tail test, because it is the right tail test, right? For the one tail test with alpha equals to, how much was alpha? 0.05. Alpha is 0.05 and one tail test. You look at that. One tail alpha 0.05. What is the degrees of freedom? Is 19, right? Go down to 19 degrees of freedom. Look at that. 1.729. That's what there. 1.729. One tail test, alpha is 0.05 and 19 degrees of freedom is 1.729. If that 1.7291, so it is the same value. You can use table or you can use the calculator. The calculator is easier. Let us do another example. Example number 2. It says find the t value for alpha is 0.05, n is 20, but left tail. In case of the left tail, the left area is given. That's what the calculator needs, right? 0 is in the middle, and then that is the 0.05. You need to find out negative t alpha. Since it is the left tail, the t value, the t alpha value will be negative. That's why I wrote negative t alpha. So how do you find out that? Is negative t alpha equals to inverse t, right? What is the area to the left of that? Is 0.05 and then degrees of freedom is 19 again. Okay, how do you do that? You will get negative 1.7291 if you do that. Okay, so let me show you that. So instead of, let me copy that, inverse t, right? And then instead of 0.95, we will have 0.05. So let me make it 0.05. And then the 19 degrees of negative 1.7291. That's what you get. Now, if it is the two tail, then you will have to divide that 0.05 into 2 halves, right? So 0.025. 0.025 is on the right side and then 0.025 on the left side. Now this is denoted by t alpha half because that area is the t alpha half, negative t alpha half, positive t alpha half. Now to find out negative t alpha half, what do? is inverse t, and the area left of that is 0.025 and 19. You get negative 2.093. And for this t alpha half value, what is the total area on the right, on the left? Is 95 is in the middle, and that is 2.5%. This is 95%. So 0.975. See, inverse t 0.975 and 19. If you do that, you will get positive 2.093. So this is how you find out the critical t values. Okay, so these are the steps if you want to use the t test by traditional method or critical value method. The first is state the null and alternative hypothesis. I think the second step, let me put this in the second step and this in the third step. Okay, so that will be the second step is find the test statistics. Okay, find the test statistics. What is the formula? It's x bar minus mu over, instead of sigma you have s over root n. Okay, that is the second step. So this is step number B. Step number C is find the critical t values. Critical t values. Okay, for the left tail test, inverse t alpha and then degrees of freedom. For the right tail test, inverse t 1 minus alpha, meaning area towards the left, and then degrees of freedom. For two tail test, you need to find t alpha half and then negative t alpha half, inverse t and left area, and 0 1, and that's what you do for the critical value method. Now decision is if the test value fall in the critical region, exactly the same way in the case when the sigma is given. If the test value fall, if this fall in the critical shaded region, then you reject the null hypothesis, otherwise you do not reject. Okay, similarly in the p-value method, state the null and alternative hypothesis. Okay, find the test statistic. Test statistic, this is the formula, same formula will be used. And for the p-value method, find the p-value. To find our p-value, we use the following. The p-value is the area left to the test value or the right to the test value, depending on what tail of the test. For the left tail test, p-value is the area left of the test value. For the right tail test, the p-value is area right of the test value. And for the two tail test, you need to do 2 times area left or area right, depending on where the test value falls. If the test value is positive, then you do area 2 times area right of the test value. And if it is negative, 2 times area left of the test value. And decision is if p-value is less than alpha, we reject the null hypothesis. Okay, let us do one example, then the things will be clear. Okay, guys? Alright. So what we do is a medical investigation claims that the average number of infections per week at a hospital in southwestern Pennsylvania is 16.3. What is given? Mu is 16.3. This is the claim, right? So this is the claim. So null hypothesis is basically the claim. A random sample of 10, n is 10, weeks had a mean number of 17.7. So x bar is 17.7. That is the sample mean. The sample standard deviation is 1.8. That we denote sample standard deviation by S, okay, or S or SX. Is there enough evidence to reject the investigator's claim? So what do you think? Is this the left tail, right tail, or two tail? It is two tail, right? Because I didn't see anything less than or greater than or more than or smaller than like that. Any word like this, okay? So this is the two tail test. So we will test against the claim not equals to 16.3. So what is the step number 1? Step number 1 is H0 is mu equals to 16.3, which is the claim, right? H1 is mu not equals to 16.3. This is two-tail test. Two-tail test. This is useful. The tail is useful to find out the critical value or the p-value, right? Number 2 is the test value. Test value is we denote by t or lowercase t is x bar minus mu over s over root n, right? What is x bar? 17.7 minus 16.3 divided by s is 1.8 divided by root under 10. This is what you do. If you use calculator for this, what do you get? Let me use calculator, okay? So clear everything what we have. So 17 point, let me see what was the value. 17.7 minus 16.3. Start with parenthesis. 17.7 minus 16.3 divide by, and then parenthesis again, 1.8 divide by root under 10, square root of 10, and then close the parenthesis on the denominator. Okay, if you hit enter, I get 2.4595. This is what I get. So 2.4595. So we are using traditional method. So we need to find out the critical t value. So number 3 is critical value. So alpha is 0. What is alpha? 0.5, right? So let me write down. Alpha is 0.05. This is also given. 0.05, right? And two-tailed. So when we make that, we will divide that alpha equals to 0.05. Alpha equals 0.05 into the two tails, right? So this is what you do. This is what you do. So this is negative t alpha half, because we have to half that. This is positive t alpha half. So 0.025, because we are dividing this into two halves. That's why 0.025. So what do you do? What is the degrees of freedom? By the way, n is 10. So the degrees of freedom is basically degrees of freedom is 9, right? So how do I find out those test value there? Sorry, the critical value is negative t alpha half. This value is inverse t, and then the left area is 0.025. Degrees of freedom is 9. Okay. So to find out the critical t values like negative t alpha and positive t alpha half, there are two methods, right? One method is you use the table, right? How do you use the table to find out the critical values? Is go to the table and you see, look at the two-tail test. This is the two-tail test, right? Two-tail test, and alpha is 0.05. What is the degrees of freedom? Degrees of freedom is 9. You see that? 2.262, because this is the 9 degrees of freedom, and 0.05 for two-tail test. Okay, so I use the table that I gave you in the chapter 7. So I use the same table, same t table. So basically what we got from the table is 2.262, right? 2.262, and this one is also 2.262 but negative sign. This is by using the table. But if you want to use calculator, then you get negative t alpha half equals to inverse t, and then area left of that 0.025, and 9 the degrees of freedom, right? Let us use calculator for that. So if you use calculator for this, what you get is, go to the second verse, and then number 4 is inverse, number 4 is inverse t, and the area is, the left area is 0.025, right? 0.025, and then degrees of freedom is 9, right? And then you do paste. This is what you get. So inverse t 0.025, negative 2.262, that is this value, and the other value is be positive 2.262. Okay, now if you are using the TI-84 plus CE calculator, then things will be a lot easier for that. Okay, suppose I want to use TI-84 plus CE. How do I do that? Let me do that. You do second verse and then go to the inverse t, that is number 4, hit enter. Okay, area is what? So the area is left area again. So I think it's the same thing. Okay, because you need to enter the area 0.025, right? And degrees of freedom is, what is the degrees of freedom? Is 9, right? And then paste, hit enter, and then paste it. You'll get negative 2.262. So it is exactly the same thing. For normal distribution, it was a little bit different, but for the t distribution or the t test, it is exactly the same thing. So you got negative 2.262. So the t alpha half will be positive 2.262. That is step number 3. Let us do step number 4 here. So step number 4 is now decision, right? How do we make the decision? Is this test value fall in this critical region or not? Or fall is this shaded region or not? So this is 2.45. This is 2.26. So it looks like the 2.45 is bigger than 2.26. That means since 0 is in the middle, so that falls in the critical region, right? So what do you write? Since the test value t falls in the rejection region or the critical region, in the rejection region, the critical region is also called rejection region. Okay, region we reject H0. So what is the we reject, that means what is the conclusion then? Hence there are enough evidence to reject the claim that the average number of infection is equal to 16.3. So we rejected this claim, meaning we are supporting that it is different from 16.3. So this is the critical value method. In the p-value method, you do the step 1 and 2 exactly the same. On step 3, you will find out the p-value, right? How do you find the p-value? To find out the p-value, we need to find out the area right 2 times the area, because it is 2-tailed test. 2 times the area right of that. Okay, you need to use TCDF. Okay, but now what I want to do is I want to show you how to use calculator directly on this problem. Okay, let us do that. So clear everything there and go to the stat and then test. We will use t-test instead of g-test. We use t-test. Why? Because sigma, the population standard deviation, is not given. Let me hit enter. Do you have data or statistic? We have statistic, right? So what is the mu 80 is? 80 was, let me see that. 80 was 16.3. So you write 16.3. And then what is x bar? X bar is 17.7, right? Because that's what we got here. X bar is 17.7. And what is the SX? SX is 1.8. That means the sample standard deviation, 1.8. And what is N? N is 10. N is the sample size, that is 10. And is this left tail, right tail, or two tail? It is two tail, right? Let me select that and go to the calculate. So what do you get? The test statistic is 2.4595. See, we got the same thing there, right? We got the same thing here, 2.4595. And the p-value is 0.0361. You see that? P-value is less than alpha. Because let me write down that p-value thing here. If you do by the p-value method, the p-value is 0.03, what was that? The 0.03 and then 61, right? So 0.0361. So p-value is less than alpha. So we reject 80. We reject the null hypothesis. So the conclusion is the same because we are getting the same decision, right? So we reject the null hypothesis. So the calculator uses a lot faster. It gives you the step number 2 and step number 3 directly, and then you decide depending on that. Okay, that was the p-value, traditional method. Okay, so the next thing we want to do is basically the p-value method on this problem. So if the data is given, basically, if the data is given, we can do exactly the same way. What we do is you enter the data in the calculator. How do you enter the data in calculator? Go to stat and hit enter on the edit, and you enter the data there. You enter the data, okay? After you enter the data, what do you do? Go to the second verse, and then, you go to this, I'm sorry, this is not second verse. After you enter the data, go to the stat and then go to the test, okay? And then go to the t-test. And then what do you have in that case is you enter the data. So instead of the stat, you pick the data there, and then mu0, write down the null hypothesis. Where did you enter the data? You pick that column, okay? So you pick that column. Where do you enter that? So if you enter in L1, you pick second, and then 1 will be L1. If you enter that data in L2, you do second, and then 2 will be L2, and so on. And then you calculate. You get exactly the same result if you enter the data. Exactly same way, only the difference is you need to enter the data in L1, L2, L3 like stat, and then hit enter and enter the data. And you need to pick data here, okay? It is exactly same as the process is exactly same as the finding the confidence interval, but you need to do t-test instead of t-interval. We need to do t-test. Okay, let us do one with the p-value method, and also using calculator as well. All right, let us do example number 6. The average strawberry has approximately 200 seeds. So mu equals to 200 because this is the population mean, population average. Why? Because it doesn't say anything about the sample here. So this is the population average. Okay. So A very patient student selected a random sample of 10 strawberries. So n is 10. Okay. And found a sample mean is 185.2. So x bar is 185.2. With a standard deviation is 10. So s is 10. At 0.05 level of significance, that is alpha. Level of significance is denoted by alpha, 0.05. Can it be concluded that the mean is less than 200? Okay, so it says less than. So meaning this is less than. What does that mean? That means it is the left tail test, right? So less than means left tail test. So this is the alternative hypothesis. So number 1, H0 is mu equals to 200. H1 is mu is less than 200. This is the claim. So left tail test. And then this is the claim, because this doesn't say that somebody claimed that the average population average is 200. It doesn't say that way. That's why the alternative hypothesis is the claim here. Left tail test, and this is also the claim. Number 2 is the test value t or lowercase t is x bar minus mu over s over root under n, right? So what do you get? X bar is 185.2 minus 200 divided by s is what was s? 10 over root under 10, right? Because you see that the sample size is 10, the standard deviation is also 10. So this is what you get. So if you use calculator, what do you get? Let me use calculator for that. So 185 point, let me clear what I have here. Okay, let me quit and then clear everything. So what I want to do is 185.2 minus 200, and then close the parenthesis, divide and open the parenthesis again, 10 over root 10. So 10 divided by square root of 10, right? And then close that. What do you get? I get negative 4.68. This is what I get, negative 4.68. Negative 4.68. That's what I get. Okay. Now, what is the p-value? Number 3. So alpha is 0.05, left-tailed, right? So the p-value in this case will be area left of the test statistic, right? So area left of the test statistic. See, this is 0, negative 4.68 will be here. Negative 4.68 will be here. All right. So I want to find out the area left of that. Let me say that area that you want to find out that area. Okay. So the p-value is the area left of that. So that will be TCDF negative 10 to the 10, and then the right bound is negative 4.68, right? So and then what is the degrees of freedom? So the degrees of freedom is 9, right? Because 10 minus 1 is 9. Isn't that you have to enter that in your calculator? Or you can do the table as well. I mean, table is a little bit because what is the alpha value? Alpha value is 0.05, and then you need to do the I mean, you can do the table. It's the same. It is not different at all. So what is that? Alpha is 0.05, one tail test, right? So one tail test, 0.05, degrees of freedom is 9. So 9 degrees of freedom, 1.833. That's what you get. So since this is the negative, by the way, you need to find out the so your calculator has TCDF, so you don't have to use the table for that. Okay, your calculator has TCDF. Let us find out the area, because to find out the area, your calculator has that. So what do I do is a second verse, go to TCDF. So what is TCDF? Is number 6 is TCDF, right? The lower limit is negative 10 to the 10, or here negative 10 to the 99. That is fine. Upper limit is negative 4.68, 68, right? And degrees of freedom is 9. Okay, that's what you do, and then hit enter. So hit enter again. You get 5.76 times 10 to the negative 4. That e to the negative 4 means 10 to the negative 4. So 5.76 times 10 to the negative 4. That is same as like 0.00 0.0576. Is this p-value less than alpha? So p is less than alpha means number 4 is we reject H0. We reject the H0. That means this will be rejected. So this will be supported. So which one is the claim? The claim is this one, right? Hence there are enough evidence to support the claim that average is less than 200. This is how we test the hypothesis of the mean when population standard deviation is not given. You should be careful if population standard deviation is given or sample standard deviation is given. Okay, when you read the question you can find out that, because if the population standard deviation is given, it will talk at the beginning, or it will say the population standard deviation is this much. If the population standard deviation is not given, then it says a sample of this many were taken and we found that the sample mean is this and the standard deviation is this. That means that is the sample standard deviation. Okay guys, so next thing I want to do here is I want to use calculator directly. I don't want to do all these things and I want to use calculator directly. Okay, so what does calculator give? Calculator give you the test value and calculator will give you p-value, and depending on that you will decide. Okay, so how do I do that? Is go to the stat and go to the test, okay, and then go to the t-test. If you hit enter, and we don't have data, so we use stats, and what is the H0 or the mu0 is 200. Okay, so mu0 is basically H0, so 200. What is x bar? X bar is 185.2, right? 185.2 is the x bar. What is sx? Means the sample standard deviation is 10, right? And what is the n? Sample size is also 10. So n is also 10. You see that? N is also 10. So you get that. And is this left tail test here, right? But it is not two tail. It is left tail. So go to the less than, hit enter, and then hit enter again. Go to the calculate and hit enter again. So you get t is negative 4.68. That's what we got for the test value, right? Negative 4.68. And what is the p-value? P-value is 5.76 to the negative 4. That's what we got. That is same as, see, there is negative 4 means there are 4 zeros before the decimal. There are 4 digits that's before the decimal. That's what it says. There needs to be 4 digits before the decimal. There is 1 digit already. So we need to make 4 digits before the decimal. If you want to get rid of that negative 10 to the negative 4, you add 3 zeros and write the decimal there before 5. This is what you get. And p-value is less than alpha. So we reject the null hypothesis. Basically, it is a lot shorter. Okay, you can find out the p-value right away and then get that. But in your online homework though, there are some questions they are asking the traditional method. So you need to know how to do by traditional method. But in your exam, I'm fine to if you do with the p-value method or traditional value method, traditional or the critical value method. Okay guys, thank you very much.